Hello and welcome to this episode of the SeaSharp Eurocode9 tutorials. This episode will be about defining plate fields for Eurocode9 checking. And we will start by just starting a new workspace. Then we will just select a name for it. And we say save, and then we have a new workspace. And here we create a new assembly. And in the new assembly, we right-click plate fields and say detect plate field from FEM file. And what we will do now is that we will read all the plates and stringers also that are defined on a SESAM FEM file, typically generated in Genie. And here I select this file. I say open, and you can specify the maximum stringer section height. So all beams with height larger than this will not be read in as plate stringers. So you have to check them as Eurocode9 beams instead. That's another episode of the tutorials. You can select only to import the vertical plate fields. You can select to ignore the diagonals. And then we just say OK. And we let the program import this file. And here you see that it generated a bunch of plate fields. You can visualize them in the normal way. We just click this in this square in the browser, and we zoom, and here we have all the plate fields. Now, just to make things a little simple, I will just delete all of them with the exception of a very few. So let's say we will only look at these ones. And now I press Ctrl so that the selection gets inverted. And then I just remove or delete all of these plate fields, and we're left with only these few. And then we can quickly look at the definition of one of them. It has a distance between the stringers. It has a plate thickness. It has a length in the direction of the stringers. And it has a distance between sideways support, like tripping brackets or things that are preventing the stringers from bending or buckling. And we specify the girder length, which is the length in the opposite direction of the stringer. So if the stringers are going in this direction, this will be the girder length. Then we specify the section, the material, and we see that the material is not defined yet, so it doesn't have a material. Okay, then we go into the properties. And the first thing we'll do is to define a section to apply to these plate fields. Then we will choose what's called a closed stringer section. This is often applied on these types of panels. And here you have 3 coordinates, A1, A2, A3, T2 and T3. And to see how these are defined. So this figure shows how A1 is defined, A2 and A3, and this is the plate thickness. And here we have T2 and T3. So that's what you're giving in here, and we just say OK. And then we just select the plate fields that we want to apply the section to. And then we say apply to selection. And now we go into the stringer distances. Quite a lot of different distances here, but they all seem to be kind of not very sensible, maybe with the exception of this. So we apply this to the selection. And then we have a plate field looking something like this. If we now go into the draw style, you see this lines here is what's called the geometry outline. We can untoggle that. Then we apply it to all the selected ones. And then they look like this. And they all have a thickness, and they need to have a material. So we define aluminium material. And we apply it to the selection. Now we can again have a look at it and see whether it's well defined. Yes, it has a stringer distance, it has a thickness, it has a section and a material. Sniped endpoints, we can also set that directly from the 3D view. So here I can go in and say sniped stringer end support on selected bulkheads or continuous. And I can set the string length equal to the points distance. And these actions are more for specialists. Where you can define plane, and you can split. If I had a plane going normally on this plate field here, I could split it at the desired location. Now what you have to be aware of is that the program is matching the position of this plate field with the plates defined on the FEM file. And if you split in the middle of an element, it may be difficult to detect what the stresses are at the boundaries. So should be a little careful with that. And if we now go back into this definition of the plate field, we see that we have the option to rotate the stringers, invert the plate normal, and then we are basically happy. Now I can visualize all the points here, which is quite a lot. And there you see that there is a point at each corner of the plate field. And that completes this introduction into the plate fields. Thank you.